These are the notes for Unit 7, Day 2, and these notes, the title of them is called Nice Form, and so what we're looking at is we're looking at the kind of the basic sketch or the basic shape of a polynomial, and so we're going to start with a quadratic, and this quadratic is listed below, and it's written in factored form. And so if we remember what that means it's written as y equals a x minus p times x minus q, right, where the p and q are the intercepts. So if p equals 2 and q equals, if p equals -2, right, because x minus p would have to be, this would have to be written as x minus a -2. So if p is -2 and q is 3, those are the x-intercepts. So we'd have an x-intercept at -2, we'd have an x-intercept at 3, and then in general, we know that since a is equal to 2, that's positive, so it opens up. And so we know we have something in general that looks like this. I'm going to erase that though. So let me get rid of that because I want to locate that y-intercept. And if you remember, so x equals -2 and x equals 3 are the x-intercepts. The y-intercept you can get by plugging in 0 for x. So it would be 2 times the quantity 0 plus 2 times the quantity 0 minus 3. And so that is 2 times, the first bracket ends up being 2, the second bracket ends up being -3, so that's -12. So with that y-intercept, then we can graph it a little more accurately. So we have something that kind of looks like this, roughly. It doesn't give us too much information. It doesn't tell us what the vertex is. It doesn't tell us any of that stuff. We know the quadratic is symmetrical, so we could find where the vertex lies. So in other words, if we go in 1 and in 1 and in 1 and in 1, then we have to go in a half and in a half. So here's the line of symmetry. So we know the vertex is right there. We just don't know the y-coordinate, and I don't care. We know the x-coordinate is x equals 1/2. But that's exactly in the middle between 0 and 1. And we could find the y-coordinate, but we're not going to. But finding those x and y intercepts are at least enough to give us a basic shape, and that's kind of what we're going for here today, is a basic shape for our higher ordered polynomials. So we're going to use this process that we used with the quadratic on the higher order polynomials, and that will give us a decent sketch. So how are the x and the y intercepts relate to the equation of the function? We know that the x-intercepts, the p's and q's, so to speak, those are the factors, and the y-intercept is where we spell intercept correctly there. There you go. Is when we substitute 0 in for x. So you notice that we were able to do all of this without doing that, converting it to general form. And that's true with the getting a sketch. But I do want to just spend a moment and convert that to general form. So let me go here, because that gets us something which is kind of nice. So we're going to FOIL this out. So it's going to be x times x, which is x squared, and x times negative 3, which is minus 3x, 2 times x, which is plus 2x, and 2 times negative 3, which is negative 6. So that's 2 times the quantity x squared minus x, because these are like terms, and minus 6. So distributing the 2 then, I get 2x squared minus 2x minus 12. And we can see then that the y-intercept, negative 12, just ends up being that constant term. So that's kind of nice. If we have the general form, then we can at least find the y-intercept really easily. We can't find the x-intercepts that easily, though. We would have to reverse that whole process, which is cumbersome, which is why the intercept form, or the factored form, is so much more convenient for graphing. Okay, so let's try to apply that to this. It's a cubic function. So a cubic function is ends up being x cubed. Okay, and this is, here it is in factored form. And so if you notice, before we jump into anything, if you notice, it's exactly what we had above. And then we added a third factor of x plus 1. So we can find our, so we're going to expand this, factored form expression. And we'll do that in the learning targets. So again, we're going to skip over the conversion just for a moment. But we know that our intercepts are x equals negative 2, and I want to move that down a little bit. I'm going to do a little reverse math here. That makes the first factor 0, and x equals 3. That makes the second factor 0, and then x equals minus 1 is our new factor. And so the way I can get those is I can take each factor and x plus 2 and set it equal to 0, and then solve it and get our x-intercepts. So I can do x minus 3 equals 0 and solve it and get our x equals 3 intercept, and I can take the x plus 1 equals 0 and solve it and get our last intercept. And then we're going to get the y-intercept. So the y-intercept, we're going to do exactly what we did above. We're going to substitute in 0 where we see x. So it's 0 plus 2 in the first factor, it's 0 minus 3 in the second, and 0 plus 1. So we have 2 times negative 3 times 1, which ends up being 12 again. Negative 12, excuse me. So we end up having the same y-intercept because that last factor was x plus 1. And so we have x-intercepts of negative 2 and 3, just like we did before. And then we have this new x-intercept of negative 1. So we've got to cross in those places. And so notice how it says graph the equation even before it had you calculate any of those things. The reason why it says graph the equation before it has you do any of the calculations is because we're really going to rely on our graphing calculator just until we can get comfortable with these basic shapes and connect them to the degree of the polynomial. And right now we really can't see the degree real well because it's in factored form. So we're going to go ahead and graph this. 2 times the quantity, x plus 2 times the quantity x minus 3 times the quantity x plus 1. So when we graph this, it basically looks like this. And so for the sake of just the basic form, what I'm looking for is when we talk about looking at that basic form, I'm trying to expand it so you can see all the intercepts. And so the x-intercepts, if you notice, x equals -2, x equals +3, x equals -1. So, and then those are the x-intercepts, and then the y-intercept is x equals -12. And if you notice on our graphing calculator app, it literally says y-intercept. So it's if you're a little bit off, you notice it won't say that, and it kind of snaps to those intercepts like it does here. It calls them zeros. The x-intercepts are also called zeros. So now we have this basic shape. Now we know we start low here on the left, and then we go up, and we've got that small peak there, and then we've got like a large valley. So we've got something that basically looks like that. And like I said, this is just a sketch. So how high these peaks are and how low these valleys aren't a concern to us. We just want to make sure that we're going through the correct intercepts. So that's how we're going to graph higher degree polynomials, is we're going to get a feel for where they get the locations where they cross the x-axis and the y-axis, and then get a feel for where we have hills and valleys, basically, and what's happening at the ends. So we can convert this. It's going to get a little messy, I guess you could say, but what I'm going to do is I'm going to take this, because it's the same. So let's duplicate that and bring that down here. Okay. Because in addition to that, we also have this new factor, x plus 1. So that was part of the, that would have been part of the steps to multiplying this out anyway. And then we can use an area model here to get this last multiplication. It's probably the easiest way to do this, where this is x squared, this is minus x, this is minus 6, and this is x and plus 1. So we have x cubed minus x squared minus 6x plus x squared minus x minus 6. And then we know that we have like terms on diagonals. So here's some like terms, and here's some like terms. So we end up having all expanded out. We end up having 2 times the quantity, x cubed, and the x squareds go away, and then we have minus 7x and minus 6. So we end up having 2x cubed, if I distribute the 2 now, minus 14x minus 12. And if you notice, the y-intercept is still that last term. So let me get my orange out here. Here's my y-intercept, and here it is when we calculated it. We can still, in that general form, we can still at least find the y-intercept as the constant term. And so how do the intercepts relate to the functions? I'm just going to say C1e, because it's the same. Oops. So in terms of the learning targets here, what we're really focusing on are those 2 forms, the general form and the factored form. So let's focus on that factored form first. Factored form of a polynomial. Okay, so that factored form, we're gonna kind of not expand it, but continue its pattern, maybe, right? For quadratics, we got used to seeing a times the quantity x minus p, x minus q. And for higher degree polynomials, we just add more factors. So maybe like an x minus r, and an x minus s, and an x minus t. Just kind of make it alphabetical like that. So I'm just going to go dot, 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 right? We can keep continuing that pattern of adding factors, which means that x-intercepts are taking those factors and setting them equal to 0, so x minus p equals 0, add p to both sides, and so those x-intercepts then become x equals p, and x equals q, and x equals r, and so on and so forth. And if we have a plus there, then when we solve them, we get negative answers, and stuff like that. And then to find the y-intercept, we plug in 0 for x. So we get y equals a 0 minus p 0, 0 minus q 0 minus r, which gets us a times minus p times minus q times minus r, right? And if the plus is there, then those would be positive. And so that gets us the y-intercept. And then that gets us enough to graph. And then what we would do is, if we had this in factored form, we'd graph on calculator app, just so that we're going up and down on the ends in the right direction. And that up and down on the ends is connected to that a value. If you remember, if a was negative, we had quadratics that were opening downward. And with higher ordered polynomials, it's a little more complicated to figure out, what the ends are doing. And we're going to get to that in the next section. We're going to really rely on our graphing calculator though today for this section. The second learning target is the general form. Of a polynomial. I need a little more space. There we go. Okay, so the general form of the polynomial, like if you remember for quadratics, is ax squared plus bx plus c, right? And so we follow that general pattern, but since we're talking about higher degree polynomials, we don't know the highest number, the highest degree there, right? This is the degree, the highest power, is bigger than 2. So we don't know what that is, so we just in general call it ax to the n power, which means our next term has a power that's smaller than this, at least by 1. So we say that the power in the next term is bx to the n minus 1. And then we kind of reserve c for that constant. So we could have more terms with x values that have smaller powers, but at the very end, there's a good chance we might just have a number. And so that number we're going to call c. So we kind of push c out to the end and keep that as the constant term because it's c, and c is the first letter in the word constant. And then plus, then when we collapse this for a quadratic, it looks exactly like this. And we're using c for the same thing. And we know that we align this with the y-intercept. The y-intercept here equals c for everything, for every polynomial. But if you notice, the x-intercepts are difficult, right? They're too hard to see here. It's not useful for the x-intercept, so we don't even engage in trying to find those. Okay, so if you want to do the check your understanding, you can. Let me just kind of talk about the first 2 questions or the first question on each page of the homework. But you can do the check your understanding and look at the notes on Blackboard for those solutions if you want extra practice. And shoot, I don't have the homework in this packet. So Okay, let me kind of preview the homework and through the check your understanding, since I don't have the homework put in here. Not quite sure why that was so difficult. Okay, so I'm just going to graph this polynomial here, and let's clear that out. So we've got, this is in general form, so 2x cubed plus 2x squared minus 12x. And let's graph that. Okay, so that looks like this. So because it's in general form and because I don't really feel like factoring it, I could. I just want to get this graph. So the x-intercepts look to be like -3 and 0 and 2. So -3 and 0 and 2. And so if the homework starts out by giving you graphs. And it wants you to write, it says write a possible equation. And when we say a possible equation, I mean we are going to leave it with the a as part of the equation. So for instance, if we would see something like this, we would say, well, the intercepts are x equals -3 and x equals 0 and x equals 2. And so the factors are going to be x plus 3 and x minus 0, right? Minus is part of the standard form, and x minus 2. In other words, those expressions, when we plug in -3 and 0 and 2, makes that 0. And then so we're going to keep the a out front, and that's going to be a possible equation. So your answers are going to be like this in the homework. We're not going to find a. We know in this case a is 2 because we need a coefficient of 2. But we're not going to go through all of the math and find a like we were doing in the last unit. It's not that hard, it's just that we've already kind of looked at those skills and we're not going to bring them back. Now, I do want you to be able to simplify this a little bit. In other words, ax plus 3 is fine, but x minus 0 is really not necessary. We can just call that x. And then what we typically do is if we have just an x minus 0 or an x, we bring that out front. So we would write it like this. So recognizing that this is an equivalent form is important. So at the beginning of the homework, when you're given a graph, I want you to just write it like that. Now, the one thing that this doesn't show is what happens when we have something that's called a repeated root. So a repeated root is when we have something like y equals, I'm gonna kind of base it off of this, y equals 2x, x plus 3 quantity squared, x minus 2, okay? So, what I did is I repeated, by putting a power, I repeated this factor. And so if I come back and graph that, I'm actually going to leave the first one graphed. And then I'm going to go 2x times the quantity x plus 3. Squared, so let me put a squared there, and then times the quantity x minus 2. So I gave it an extra root, which means it's now a 4th degree polynomial. And so look what it does to the graph. Okay, so it's the purple graph. Notice that where I repeated the root, so let me go to put pink here. Where I repeated the root, we get this. Instead of going through, it comes from above and then hits the axis and goes back to the same side. So a repeated root has that characteristic. So at -3 and +2, the repeated root looks like this. And then we know we have to still go through 0, so it's got to come down like this and up like that. Okay, so that's the repeated root. So then writing something with a repeated root requires a power, or it requires you to write it like this. We just repeat the factor. So when you see that characteristic on a graph, let me just highlight that. When you see this characteristic on a graph, which you'll see on the first page a lot, once in each one of the problems except for 5, you're going to have to repeat that factor. So kind of keep that in mind as you're working on the homework, on the first 6 problems on the homework. And then on the back side, you're expected to graph it. And so on the back side, it gives you the factored form of the equation, and so you know what the a value is. So on the back side, you should be able to graph that and then tell me the x